Okay, Kel, kids, this is a question that is a lot more kind of in your wheelhouse. We're out of that separable equation piece. We are given a differentiable function here, f prime, so we're given the derivative. It talks about, has horizontal tangents at x equals 1, 3, and 5. That means it's a, minimum here, maximum, minimum, so on and so forth. And it says f of 8 is equal to 4. That means we have a known condition. It goes through the point 8, 4. So I'm going to mark that down in that situation. Let's look at the first question. It says find all values for which the function f, so it's not asking about f prime, where f has a local minimum. So a lot of people would say that as a minimum, a local minimum at 1 and at, let's see, 1, 2, 3, 4, 5. That's not correct because that's f prime. It's wondering about f. So we are going to look for where f prime changes negative to positive. And where does the derivative change from negative to positive? Well, right here. So that's going to be at a value of 6. That happens at x is equal to 6. So x equals 6, you have a local minimum in that spot. Okay? All right. Part B. Part B can be a little bit confusing. And what it's asking about, it says determine the absolute minimum value of f on the interval 0 to 8. Well, anytime it asks about absolute mins or maxes, we need to check a few points. We need to check number one, the beginning. We need to check the end. And we need to check then any spot where the derivative is equal to 0 for the minimum. That's going to be at 6. But we've got to kind of work backwards in this spot to some degree, okay? And I'm going to bring up this situation. So we have this relationship. We're talking about f, but we're given f prime. Well, the integral of f prime is f. You know, if you take the antiderivative of f prime, you get f. And this is also the area thing. So if we look at area, that's going to tell us something about f, okay? So let's just pick a starting spot, okay? Suppose, we'll use, I'm going to use these points where I know my area. So we're going to start at 0, and we're going to go to 1. Okay, I'll write over here 0, 1, and then we got a new area 2, 3, 4, and we got 4, and then we've got 5, 6, we got 7, 8, okay? And it looks like it says that we gain 2 areas right there. So suppose we start at 0. By the time we get to 1, we are actually gaining 2. We gain 2. Then we got 1, 2, 3. So at 4, we've gained 6 more, it looks like. Should be up to 8. Then here we lose 3, so we'll be down to 5. And then it says we gained 7, so we would be up to 12. So, but it tells us that at 8 we only have that it's not 12, it's actually 4. So it turns out that that's 8 more than what we thought. So we just subtract 8 off of those, and we get negative 3. We get 0. Subtract 8 off of that, we get negative 6. And I'm sorry, we don't want to subtract 8, we want to subtract 4. We want to subtract 4. Uh, or no, that's right. We subtract 8 and then negative 8, okay? And so as you look at this data, you could tell then that at 0, f is equal to negative 8. And at 6, it's equal to negative 3. And at 8, it's equal to 4. So in fact, the absolute minimum is negative 8. It happens right at the very beginning. Okay? Let's look at question C. Question C says, on what open intervals is the graph both concave down and increasing? Well, concave down, we are looking for f double prime to be negative. And for increasing, we're looking for f prime to be positive. So let's consider where f prime is positive. This is f prime, and it's positive here because it's above. It's positive here because it's above. It's negative here, so the function's decreasing that area. And then it's increasing here. So we have lots of areas where it is increasing, okay? But now f double prime, that would be the rate of change of f prime. So if you would consider the slopes, like we're headed down here. So f prime is positive, it's above the x-axis, but we're trending downward. So we're looking from 0 to 1. And then it looks like f prime is positive and f double prime is positive. But here f prime is positive because it's above the x-axis, but the slope is negative, so f double prime is negative there. So we're looking from 3 to 4. And then that looks like it's it, and those two values. And that's absolutely correct. Making this statement is extremely important in your answer. And then finally, part D. Part D talks about the function defined by g of x is that if f of 3 is negative 5 halves, find the slope of the line tangent to the graph of g at x equals 3. Slope of the line tangent to the graph g at x equals 3. So really what I'm looking for is, I'll write this down, g of x is equal to f of x, that quantity, cubed. I know that f of 3 is equal to negative 5 over 2. Okay? So it wants to know the slope at 3. So I'm looking for g prime of 3. Well, first let's focus on g prime. And if you do that, you have a composition function. You have u cubed and you have f of x. The derivative of f of x is f prime of x. And the derivative of u cubed is 3u squared. So you get g prime of x is equal to 3 times f of x squared times f prime of x. I'll write that out again. G prime of x is equal to 3 times f of x squared times f prime of x. Well, if we type in 3, that's going to be very important there. So g prime of 3 is equal to 3 times, what is f of 3? It's negative 5 halves. We're going to square that times f prime of 3. Well, this is the graph of f prime. And 1, 2, 3, it has a value of 4. So I get 3 times 25 over 4 times 4. Those cancel. I get 75 is the result. And that, in fact, is correct. So there you go. There's another one. You guys are doing a great job. And not too many more to go.